Welcome to Paper Trail, where we make academic research accessible and engaging. Let's see what the evidence says. So imagine this. You're building a groundbreaking piece of software. It's working, but it's a bit clunky, full of patches, maybe not the prettiest code. And you think, you know what? Let's just scrap it. Start fresh, build it right this time.
And if you're a software developer, that thought is probably the most seductive, dangerous idea you'll ever have. Because according to one of the most foundational essays in software engineering, doing that is the single worst strategic mistake a company can make.
The single worst? That's a pretty bold claim, especially coming from an essay written back in 2000. But the evidence presented in this report suggests that not only was Joel Spolsky, the author, right then, but his unshakable law might still hold true even in our AI-driven world.
It's a fascinating look at what we think of as progress. We're talking about a world where AI can practically write code itself, and yet the fundamental human and strategic pitfalls of software development seem to stubbornly persist.
So, let's start at the beginning. This idea, this law, comes from an essay titled Things You Should Never Do, Part 1 by Joel Spolsky. What was his core argument back in 2000?
His core argument was really blunt. Never rewrite your code from scratch. He said it's a seductive but deeply flawed fantasy. Programmers, he argued, look at existing code and see a mess, and they're convinced they can build something better, cleaner, faster, without all the old mistakes.
And he says that's flawed. Why? Because what looks like a mess actually contains something incredibly valuable.
Precisely. Spolsky's key insight was this concept of embedded knowledge. He wrote, and I'm quoting here, "When you throw away code and start from scratch, you are throwing away all that knowledge, all those collected bug fixes, years of programming work. It's like demolishing an old, cluttered library because you think you can build a new, modern one faster. But in doing so, you lose all the actual books and the wisdom they contain."
That makes a lot of sense. You're not just getting rid of bad code, you're getting rid of the history of problems solved. And the prime cautionary tale he used was Netscape. For those who might not remember, Netscape was the browser of the early internet.
Absolutely. In the mid-90s, Netscape Navigator dominated, sometimes capturing 80–90% of the browser market. They were the commercial internet. But then, Microsoft's Internet Explorer came along, bundled for free with Windows, and the competition got fierce.
And that's when Netscape made their fatal strategic error, according to Spolsky.
That's right. Instead of incrementally improving their existing browser, Netscape management decided to scrap it all and rewrite Netscape Communicator 4.0 from the ground up, aiming for a new, standards-compliant version, Netscape 6. The plan was noble, the execution disastrous.
How disastrous are we talking? What was the timeline here?
Well, the rewrite took nearly 3 years. In the rapidly evolving internet economy of the late 90s, 3 years was an eternity. During that time, Netscape couldn't release any major new versions, essentially freezing their product while Microsoft was iterating relentlessly. The market share numbers tell the story. Netscape went from 86% in 1996 to just over 50% by the end of '97. By September 1998, Internet Explorer had overtaken them.
Wow. And when Netscape 6 finally launched in November 2000, what happened?
It was a commercial and critical failure. Slow, buggy, unstable. By then, IE's market share exceeded 80%. Spolsky's essay, published months before the official release, was prophetic. The rewrite didn't save Netscape. It accelerated its demise. It was a multi-billion-dollar business destroyed, in part, by this single strategic mistake.
That's a stark example. But Spolsky wasn't just talking about Netscape. This never rewrite idea resonates with other well-documented phenomena in software development, like the second system effect.
Exactly. This concept was first described by Frederick P. Brooks, Jr. in his seminal 1975 book, The Mythical Man-Month. He noticed that after building a successful first system, architects often get overconfident. They want to incorporate every feature they deferred the first time around, leading to an over-engineered, bloated, and overly complex second system.
So the first system is usually lean because you're cautious, but the second one is where you get ambitious, trying to do too much.
Precisely. Brooks called it dangerous, and Netscape's attempt to build a revolutionary new browser from scratch, incorporating a host of new architectural ideas, is a classic example of this second system effect playing out. They were emboldened by their initial success, but that ambition led to their downfall.
And then there's the moving target problem. This sounds like something that would plague any long-term development project.
It's a fundamental strategic flaw of the big rewrite. While you're busy building your shiny new system, the old one can't just stop. It still needs to serve existing customers. New features still need to be added to remain competitive. This creates a debilitating split. You're effectively running two parallel development tracks.
So any new feature added to the old system during the rewrite has to be incorporated into the new one as well. That sounds like a scope nightmare.
It is. It leads to duplicated effort and a constantly expanding scope for the rewrite project, making it a seemingly endless development cycle. The new system is perpetually behind the evolving market needs. It's a longer, harder, and more failure-prone path than many anticipate.
You'd think after Netscape, companies would learn this lesson, but the report highlights that these strategic dangers are timeless, with examples from well after Spolsky's essay. Dig v4 and Friendster are called out.
And they are excellent examples. Dig was a pioneering social news aggregator, but in 2010, they launched Dig v4, a complete redesign and rewrite. It was plagued with bugs, removed popular features, and was perceived as favoring large publishers. The backlash was swift. Users fled to Reddit, which was much smaller at the time. The rewrite essentially killed the company.
That's incredible. So a redesign, a rewrite, can actually be a corporate killer. What about Friendster?
Friendster, one of the earliest social networks, struggled with scaling. They embarked on a series of redesigns and rewrites, which stalled development. The site became notoriously slow. Page load times sometimes exceeded 40 seconds. This created a massive vacuum, a window for competitors like MySpace and Facebook to swoop in and capture the market. They were chasing a perfect new system while failing to evolve their working one.
So the core warnings from Spolsky, underestimating complexity, the feature freeze, alienating users, they're still relevant today. It really does seem like an unshakable law. But this report also brings in the major disruptor, AI. How does AI change this picture?
This is where it gets really interesting. AI, particularly large language models, are fundamentally transforming how developers interact with and improve existing code. AI-powered tools are now acting as intelligent refactoring partners, automating many of the tedious and error-prone tasks that Spolsky advocated for doing incrementally.
Refactoring partner. So not rewriting, but improving the existing code structure while preserving its functionality. Things like renaming variables, extracting duplicated code, simplifying logic.
Exactly. In 2000, this kind of large-scale incremental refactoring was manual, laborious. Today, AI tools like GitHub Copilot and Amazon Code Whisperer are integrated directly into a developer's workflow. A developer can highlight confusing legacy code, give a natural language prompt, refactor this to be more descriptive, and Copilot suggests a cleaner version. It can even generate unit tests to ensure the refactoring doesn't break anything.
That sounds like a game changer for tackling technical debt. Code Whisperer does similar things, right?
Yes, Code Whisperer offers similar real-time code suggestions. A notable feature is its ability to perform security scans on existing code, identify vulnerabilities, and then provide generative AI-powered suggestions to fix them. So these tools are directly addressing Spolsky's point about incrementally improving code, but doing it at a speed and scale he couldn't have imagined.
And the report cites some pretty impressive numbers from 2025 and 2026 regarding efficiency gains.
They are remarkable. McKinsey reported that generative AI can accelerate tech modernization timelines by 40 to 50%. One logistics company apparently cut their modernization timeline by more than half by using AI to transform legacy COBOL modules into a cloud-native Java environment.
Wow,
COBOL to Java. That's a significant leap. And what about technical debt, that accumulation of quick fixes and compromises?
Organizations using AI-driven refactoring have reported a 40% improvement in code maintainability and a significant reduction in new technical debt. Some estimates suggest AI can reduce the time required for complex modernization by 40% to 50%, plus improved quality, 40% faster code review cycles, and 60% fewer regression bugs.
Those are staggering figures. It sounds like AI is making the incremental approach, the one Spolsky championed, not just wise, but incredibly efficient. But this leads to the central question. If AI can do all this, is it bending Spolsky's law? Does it make the big rewrite less dangerous?
This is where the report gets very nuanced. One of the biggest barriers to modernizing or even replacing a legacy system is simply understanding what it does. These systems are often poorly documented, with crucial business logic embedded in the code, and often that knowledge leaves when the original developers do.
So AI becomes a software archaeologist. It can dig through decades-old code and make sense of it?
Precisely. LLMs can analyze vast, complex code bases and perform tasks like automated documentation, generating human-readable explanations of modules in plain English. This dramatically reduces the learning curve. They can also untangle complex dependencies, creating visual maps of how different parts of the system interact.
That's huge. A high-level architectural view that might have taken a human team months to piece together.
And AI can even infer the intent behind the code. The report mentions Forte Group using LLM agents to generate natural language summaries for over 12,000 functions in a legacy insurance platform, making the system's functionality explorable through a semantic browser. This automated comprehension phase significantly lowers the risk for any modernization effort, whether it's refactoring or a potential rewrite.
So AI helps you understand the old system, and if it can write new code, does that mean it makes a full rewrite less dangerous now? Can AI just rewrite the whole thing for you?
The answer, according to the report, is still a nuanced not really. While AI can dramatically accelerate the coding portion of a rewrite, it doesn't eliminate the core strategic risks Spolsky identified. You still have the moving target problem, the danger of a feature freeze, and the loss of implicit knowledge.
So AI doesn't solve the strategic challenges, just the tactical coding ones.
Exactly. And experts caution that current AI models still have significant limitations. They often lack domain context. They know what the code does, but not why certain trade-offs were made, or the specific business rules behind it.
It's like asking a brilliant but inexperienced junior programmer to rewrite a complex system they don't fully understand.
A very apt analogy. And AI models can also be confidently wrong. They can produce plausible-looking code that passes some tests, but contains subtle bugs, performance regressions, or security vulnerabilities. Martin Fowler is quoted saying, AI output should be treated as a pull request from a rather dodgy collaborator that requires rigorous human review.
A dodgy collaborator. I love that. So you can't just trust it implicitly. And what about high-level architectural decisions?
The report notes that AI isn't yet capable of making those complex architectural decisions or understanding the trade-offs involved in designing a new system. An experiment in early 2025 to have leading AI models completely rewrite a multi-file legacy application actually failed. They couldn't process the entire codebase or produce a complete functional rewrite.
So the consensus is that AI is a powerful assistant, but human supervision and judgment remain absolutely critical. It excels at the heavy lifting, the boilerplate, the code translation, but not the deep thinking.
That's right, and this leads us to the most promising development in this space, a new hybrid approach that really bends but doesn't break Spolsky's law. The report calls it the ship of Theseus approach.
The ship of Theseus, like the philosophical thought experiment where if you replace every plank of a ship, is it still the same ship?
Precisely. In software, it means progressively replacing parts of the legacy system with new, modernized components. The new code acts as a proxy, initially redirecting to the old system. Then, feature by feature, the new implementation is built and swapped in, while the old code is slowly deprecated and deleted.
This sounds like an incremental rewrite, but supercharged by AI.
That's exactly what it is. It avoids the stop-the-world danger of a full rewrite because the system remains operational and can continue to deliver value. It's a gradual process, allowing for continuous learning and course correction. And AI tools are used at every step to understand the old components, generate new code, translate business logic, and create tests.
So AI isn't enabling a Big Bang rewrite, it's enabling a faster, safer, continuous modernization strategy that actually honors Spolsky's core wisdom.
That's the key takeaway. It transforms the rewrite from a single high-stakes gamble into a continuous, managed process of renewal. It's the best of both worlds, leveraging AI's speed and scale while adhering to the strategic prudence of incremental change.
This has been a fascinating journey from the early internet to the cutting edge of AI. So, to wrap up, what are the absolute key insights listeners should take away from this discussion?
I'd say first, Spolsky's core strategic principles are still very much alive. The dangers of the second system effect, the moving target problem, and losing embedded knowledge in legacy code are timeless risks in software development.
And the second insight?
AI hasn't invalidated those strategic warnings, but it has fundamentally changed the mechanics of how we deal with legacy code. Automated, large-scale refactoring makes the incremental improvement Spolsky advocated for faster, cheaper, and more efficient than ever.
So it's about how you do it, not if you should do it.
Exactly. And a huge part of that how is AI's third contribution, understanding legacy systems. AI's ability to rapidly analyze, summarize, and document complex code bases drastically lowers the risk and cost of engaging with old code, making previously daunting projects much more manageable.
And finally, the future of software modernization isn't a binary choice between refactor or rewrite.
Absolutely. The modern AI supercharged approach is a hybrid one, continuous, incremental modernization using the ship of Theseus strategy. It avoids the catastrophic risk of a Big Bang rewrite while still achieving the goal of a modern, maintainable system. AI acts as an accelerator for this safer, more pragmatic approach.
It's almost like AI has given Spolsky's law an upgrade. It bends, but it hasn't broken.
A very precise way to put it.
So, for listeners thinking about their own projects, whether it's code or even just processes in their own lives, perhaps the question isn't whether to start over, but how to continually and incrementally improve what's already working, and how much hidden knowledge might be embedded in the systems we're quick to dismiss as a mess.
Keep reading the fine print.